Okay, so we're going to solve this function where c is the closed curve, as we can see here, determined by the x-axis with the straight equal to x equal to 2 and the curve, which is this 4y equal to x to the third. So we're going to use Green's theorem for this problem. Green's theorem states this. Alright, b dx plus q dy, which is equal to this, to the derivative of q with respect to x, the derivative of b with respect to y, d of a. Now we're going to get those partial derivatives. So we're going to state this as p and this as q. So let's do the partial derivatives, which will be x, y, dy, d of x. Now, as we know, when we are doing these partial derivatives, this y is going to count as a constant. So this is going to be like this. X, dy, which is going to be the derivative of x is going to be 1. So it's going to get like this. Now we do the same both with p and with respect to y. X plus y dx d of y. Now we take x as a constant. So a constant, the derivative of a constant is 0.
Sure.
So it's going to get this. Yes. The derivative of y, it's 1. So it's going to be like this. Now we're going to need to know the range here. We already know that in this part of the straight line it's 2 and it's going like this. So it's this part. Now the curve, we need to know the curve. So that's why they give us the function. So we're going to put it here. 4y equals to x to the 3. Now this is going to be x to the 3 over 4, right? And it starts with 0. They both meet at 0. So we can now finally get our function, which is going to be 2 to 0. Now x to 3 over 4, 0. And this is where we sum. So this is equal to y minus 1, which is this d to the y, d to the x. Okay, so we've got our function now. So the next thing we need to do is integrate, which will be fairly easy. The integration of this with respect to y is going to be y squared to the 2 minus y. This is our first derivative, and we've got to evaluate it. Well, not derivative, integral to evaluate it here. And it's going to be like this. So now we're going to do this, which is going to be x to the 3 to the 4 square over 2 minus x to the 3 over 4, and this is going to minus 0 minus 0. Now we're going to take a closer look to this. So this is going to be x to the sixth over 16. This is going to be like this. We're going to do sandwich law, alright? So it's going to be x to the 6 over 32, and now minus x to the 3 over 4, and this is going to be 0 minus 0, which is going to be 0. So we get this, alright? So now 2, 0, x to the 6 over 32 minus x to the 3 over 4 dx. Now this is much easier. Now we only have one integral. So it's going to be this. The integral of this is going to be constant 1 over 32, and this is going to be constant 1 over 4. So we get them out. We're going to keep them in mind, alright? So the integral of x to the 6 is x to the 7 over 7 times 32. And this one is going to be fairly the same. 4, which is 4 over 4 right here, alright? So we will eliminate this because we already integrated 0. I'm going to get that off. I'm going to erase this so we can get more space, but this we already know, so it doesn't matter if I erase it. Now we follow this right here. So 7 times 32 will give us x. Oh, this is going to give us this minus x to the 4 times 16 2 over 0, and now we've got to replace. So it's 2 to the 7th time over 224 minus 2 to the 4th over 16th, and this is going to be 0 to 7 minus 1 divided by this, 0 fourths divided by this. So now we're more closer to our result. I'm going to do this with a calculator. So 2 to the 7th over 2 to 4 will give us 4 sevenths minus, well, this is 2 to the 4 over 16. It's going to be 1. So this is going to be minus 3 sevenths, and this is our result, minus 3 sevenths. Thank you.